Hello and welcome to a calculus tutorial by Physics Man Education. In today's tutorial we're going to be talking a little bit about complex numbers. Now you may remember when we were solving the quadratic formula that there were three general cases. You could have two real roots, you could have one real root, or you could have no real roots. Having no real roots happens because you have to take the square root of a negative number, which results in two complex roots. We didn't really talk much about what that means or how you would solve such a thing. We basically commented that there's no point in solving it because no real roots means that there's no x-intercepts. But there are still imaginary roots or complex roots, and we're going to talk a little bit about what that means. So, let's start with this. If we write down this situation, x squared is equal to a, that implies that a must necessarily be a positive number for any real value of x. And what we mean by a real value of x is equal to negative infinity to positive infinity, any number in between that you can possibly imagine. Well, we can demonstrate this quickly. Let's imagine first that x equals 2. X equals 2. X squared is going to equal to 2 squared is equal to 2 times 2 is equal to 4. And that's A. A is a positive number. There we go. What if we were to take x as a negative number, or like x equals negative 2? Well, if we write x equals negative 2, then we have x squared is equal to negative 2 squared is equal to negative 2 times negative 2. We already know that this number's magnitude is a very important word in a lot of different disciplines, physics being one of them. We know that the magnitude of this number will be 4. But what about its sign? Is it positive or negative? Well, when you multiply a negative number by another negative number, the two negatives will cancel. So this is actually plus 4. So as you can see, whether x is a positive number or a negative number, a will still be a positive result. Great. But what if we force this situation now? What if we force ourselves to try and come up with a solution of this? X squared is equal to negative a, where we've already determined that a must be greater than 0. If a is greater than 0, then negative a is obviously a negative number. But there's no real value of x that will result in a negative number here. But let's try to find some solution of x anyways. Well, we can take the square root of both sides, so we can say x is equal to the square root of negative a. And we need our plus or minus sign here, which is why when we do the quadratic formula, we wound up with two solutions, you remember. Problem is, we can't actually solve this. If you were to enter this into your calculator, the square root of negative a, where a is some number greater than 0, your calculator will go, dummy, we can't do that. So, we're going to factor out the negative 1. So we'll say x is equal to plus or minus square root of negative 1 times a, and we can make this two square roots now. So the square root of negative 1 times the square root of a. And that's great, because your calculator can tell you what the square root of a is. The calculator can always find the square root of a positive number. This, your calculator still can't tell you though. Your calculator can't tell you that x is going to equal to something is equal to the square root of negative 1. Which is why we define this to be the imaginary number. So, we define that I is equal to the square root of negative 1. Can anybody tell you what this number means? Absolutely not. Is it useful? Yes. In a lot of advanced physics courses, especially quantum mechanics, we have to deal with these complex numbers all the time. So this particular complex number would come out to look like this. X is equal to plus or minus I times the square root of a. Nobody knowing what I is, any number that has I involved in it is not a directly measurable quantity, whether it be physics, economics, or any other discipline that involves math. But what if I were to say x is equal to plus or minus, well, we can take the plus or minus away. We're just going to say I root a times I root b. Perhaps here I should use a variable other than x. I'm going to use y, because I don't want to confuse you. I've already said that x is equal to that. Well, this would give us I squared times root a times root b. A and b are real numbers, and you can plug that into your calculator and get an answer. Let's deal with I squared. See what I did here? I made the substitution that I is equal to the square root of -1. But when you square a square root, the square root goes away. So I wind up with -1 times the square root of a times the square root of b, which of course is going to just equal to minus root a root b. So this is why complex numbers can still be useful, because you can have two complex numbers and you can do math with them and result in a real number. Now, one more comment about complex numbers. Not all complex numbers come in this simple of a format. In fact, you could generally have, if u is a complex, well, I should say maybe w is a complex number, we could write that as u plus iv. This term here, u, is just a real number, and v is a real number, but I times v is a complex number. So the whole thing is a complex number or an imaginary number. And this is one possible format. We could also do other fancy things using exponentials. I'm guessing that at this point you're not that familiar with exponentials yet. We will be doing tutorials with exponentials in the future. Exponential complex numbers show up all the time in quantum mechanics. But that concludes this particular tutorial. I hope you understand complex numbers a little bit better. This was produced by Physics Man Education. I'm Physics Man. I'll see you in the future.